We have understood in the previous video the basic static analysis, how to get more information about the malware functionality through strings, through the PE header, and understand what this malware might be talking about. Also, it's helped us to understand what might be the behavior or the defenses this malware has to detect sandboxes, to detect our malware analysis lab, to detect some malware analysis tools, or even it can tell us what processes it's more likely to inject into, if it's a banking Trojan, so it's looking for specific banks, what's exactly it might be doing. And this will help us customize our behavior analysis based on these inputs. There is two types of behavior analysis. There is the automated behavior analysis with Sandbox. Some of the most known sandboxes is Cuckoo Sandbox. It's a free product. You can install it in your own machine. You need a host and a virtual machine, and it will do everything for you. It will run the malware on the system, keep the malware running for a bit of time, collect information, and give you a report about this malware. This is the most known sandbox, and it's easily to be detected by attackers or by different malware families. Other sandboxes, which is online sandboxes that rely on more commercial-based type of sandboxes, is malware.com, hybridanalysis.net, virustotal.com, and last and the most important is Ini.run. Ini.run is more advanced type of sandbox, and as well they allow you to download samples easily, so you can look at other samples. It can help you understand what's the family it is, what exploits it might be using, and so on. So Ini.run, VirusTotal, Hybrid Analysis, all of these websites really helpful to understand the malware functionality if you are allowed to upload that malware. Some companies will not allow you to upload the malware. Know that the attacker might also know that his malware has been uploaded because he has the hash of his own malware, and he can monitor these websites to see if you have detected him inside your environment. So you can use them at your own risk, as well as if you are learning malware analysis. These are good resources to download the sample, especially Ini.run and Hybrid Analysis. This is for the automated way. There is also another way, which is the manual behavior analysis. That will help you. You can create your own system where you will run the malware inside and simulate that it's running on a victim machine. You can have some tools to monitor the behavior of that malware. Some of them are like Network Monitor or Wireshark, which we used in the previous module. You can use FakeNet to simulate the internet communication, especially if you don't want your VM to be connected to the internet. You can also monitor registry changes using process monitor, file changes and process changes, and after the malware runs, you can also perform the live forensics the same way we have performed before, or even perform memory forensics. For the sake of time, we will not be able to show a demo of that, but you have seen how live forensics work. And with manual behavior analysis, the difference is you run the malware and you monitor it while it is running. You have Wireshark is already open before, you have Process Monitor is open, you are filtering with Process Monitor only with the name of the sample you want to analyze, and you see the changes this malware is doing to the system live from the beginning to the end. And after the malware finishes, you can, or after the timeout for your own manual behavior analysis stops, you can now basically take a memory snapshot and look at the changes that happens in the whole memory. You can use memory forensics tools, or you can use the live forensics tools that we did last module, and actually see what the changes this malware has done to the system. Did it inject another process? Did it change some? Did it load some suspicious libraries? And what exactly it did on the system. So that will help you understand what the malware is doing. To prepare your lab, you will need to have a Windows machine on VMware or VirtualBox. preferably installed on host only, so it doesn't connect to the internet. If you use NAT, if you use Bridget, it might be able to see all the machines connected to your own network. If it splits through network, it's very, very dangerous to your own host machine and to any device connected to your router. If you use NAT, it will not be as dangerous, but still it will use your own IP to do malicious activities. So the best option is to use host only and not connected to the internet. If you have bigger memory on your laptop and your laptop is more advanced, you can use actually two virtual machines. One is used for Tor, which has one virtual machine, Linux virtual machine, has two network cards. One is Bridget and one is host only connected to your malware VM. And with this Tor virtual machine, it connects to your malware VM as well as connects to the internet, and it is the default gateway for your own malware VM. With that, you can make sure that your malware VM is only using Tor internet. Tor is a known public VPN, and you make sure that your malware VM is only connected to this VPN. It doesn't use your own IP when it connects anywhere else, and it is in a very safe, contained environment. You can install the tools we have described in this module, or you can use Flare VM, which basically includes all the known tools that you might need for malware analysis. Once you prepare your VM, you install, you go into this GitHub repository, download everything there, click on the installer. It will install all the tools you need on your VM. Then save a snapshot of this clean state of your VM, and then use this state to run malware on that system from now and then. So that's for the behavior analysis. And as you might know, behavior analysis does not always give you all the information. The malware can easily detect it. You might not see different paths the malware can go to. Maybe it wants a system that's x64, not 32. It might need some changes. So it's not always the best option, or not always will give you all the information you need. Even with basic static analysis and behavior analysis combined, they cannot tell you everything about the malware, which will lead you to code analysis. Code analysis is always important, or in many cases it is very, very important. It confirms that what you saw in the behavior or you saw from strings actually represents the malware functionality, the real malware functionality. And as well, it helps you to understand different things that you couldn't see inside the behavior analysis or the basic static analysis. And today, we will not go very in-depth into the code analysis. We'll not be teaching simply and how it works and everything. What I want to show you today is that you can still perform some level of code analysis, even if you don't have any experience in assembly, or you don't have any experience with the scripting language you are trying to analyze. Today we will look at how to look through the code for some information and some clues that can help you understand the malware behavior and do some sort of code analysis. Of course, this will not work every single time with all the different malware, but it will work for so many samples, and it will help you analyze the simple tasks. And you can leave the in-depth malware analysis part to the malware analyst if there is one, or you can dive deeper. If you like that topic, you can dive deeper into the malware analysis. So I want to say something from the beginning. Code analysis is not about programming. It's not about in-depth assembly, understanding the assembly. It's about finding clues. So many times I analyze scripts from different languages that I never wrote a single line of code in them. Sometimes I analyze Perl scripts, PHP scripts. Well, I wrote some lines in PHP before. Sometimes I analyze I've been analyzing PowerShell from before I learned PowerShell. I've been analyzing so many different scripts before I actually learned how to write in these languages. And the reason that I am able to understand all of the scripting languages is that I'm able to find clues inside that code. The commands that the commands that this program is using. Most of the time, whenever a scripting language or an assembly program or like an executable program, um, these programs or these scripts, they use kind of commands that has been given either by the operating system, Windows, Linux, or Mac, or by the interpreter of these languages like Python interpreter or .NET interpreter or whatever the interpreter they are using. These commands can tell you a lot about the functionality of that malware. We have seen the import table and the functions that's included inside the import table. And these functions themselves can give you some clues. You can also see inside the assembly how these commands or these APIs are being used. APIs or Windows commands are exactly the same thing. How they are being used and what parameters they are taking. If you see an API that's called download or URL download to file, which basically download a file from the internet and save it somewhere, and then it takes two parameters. One parameter is a URL that's been given with malware.true/malware.exe, and then it will be saved in and the second parameter is basically a path inside the temporary files or the temp, and it's called 123.temp, for example. That will tell you that he's now trying to download a file from malware.true. It's called malware.exe, and this file will be saved with the name 123.temp inside the temp folder. You don't need to understand all the code to see the connection between this API and these parameters that are being given. As well, if you are doing a full in-depth malware analysis, you don't need also to, or like assembly, understanding the assembly and really understanding what the malware is doing. You don't need to understand every single line in the code. All you need to do is to connect what you have analyzed through basic static analysis and behavior analysis with what you see in the code. Find a connection between them. We'll see now we can pivot our analysis from a suspicious string we have found inside the malware or an important API, a key API like let's say download file or HTTP connect or an API for resolving domains like GitHost by name. All of these different APIs can tell us more about the malware functionality, and we can just directly go into the code that uses these commands or uses these APIs or use these strings, and from there start to analyze the malware. So we see what are the parameters that have been given to these commands, or where the string has been used, and what's happening after the string is being loaded in memory and is being used. Maybe maybe we see a string like a debug a message that's being sent to the attacker or being used while the malware developer was developing the malware and is getting printed on the screen. Maybe we see maybe we go through a link basically or a URL that's being saved inside strings, and we see where this URL being used and what API is being used there and what functions around that URL, so we can see all the commands that being sent and received by the attacker. We can see the part where he decrypts the attacker responses, where he sends the attacker requests, when he sends responses, and so on. So we can understand so much just by pivoting with one suspicious or one question that we have about this API, about this suspicious string, and we can understand the code around that area. As well, you can be running the malware in a debugger while you can stop the code when the suspicious string is being used, or when this API that you want to monitor is being used, and see what is the changes happening in memory. Maybe this API is move file, but you don't see the parameters that are being used, and when you set your breakpoint or use the debugger to stop exactly on this function move file, you will see in memory the both source and destination for the file to move. You will see the both paths have been is appearing in the memory. Clear text, you can know in clear text you can see the exact place where the file will be moved and the place where it will move to. So even if you don't see that inside the code in the first glimpse, you can see that while you're doing dynamic code analysis and looking at it in the memory. So examples of that, something like here, for example, this malware can include some interesting strings, something like connect to beer and then this function has failed, or receive line has failed, or send buffer has failed, or connect to beer success. It looks like these messages are basically debug messages for fixing the malware. Maybe the developer, when he developed this malware, he had these texts being printed on the screen or being saved in a log file, and he's reading that log file to understand. Maybe this log file is being created, and the attacker can actually get in, collect this log file and see what has went wrong and learn from them. So these strings can tell us where this connect to beer function is, and where this errors have been received, and from there we can see he's sending some messages, he's receiving some messages, he's getting some response code, get HTTP response code, which is like 200 OK or 404 or something like that. From these lines, we can see that they might all appear in one function called connect to beer, and as well they might all tell us what's exactly being sent and received from the between the malware and the attacker. We see here another commands like connect HTTP /1.0, and this looks like both of them, and the proxy authentication basic one. These two strings are basically HTTP requests. This is the exact format of an HTTP request when your browser is trying to connect to a website, or when this malware is trying to connect to the attacker website. Probably he connects to the attacker through HTTP, and this is the type of requests. And returning back to the format string, when we talked about format string in 2 earlier videos, format string looks like this. So this is connect, then it takes a string, then it takes a number, then this is basically like a template string where it's being filled with variables, filled with information. So this this percent and S represents a text parameter will be filled here, a text parameter that will be filled in here. So maybe that's an IP, and then double dots, and then percent, and then D, which represents a number, might be the port number, and then here also another information. So anyway, we see this connect, we see this connect to beer strings. If we go around as well, we see safe underscore CFG. CFG mostly represents configuration. It's like the short for configuration. So that can tell us where the malware is saving the configuration. We go more, we see as well load configuration. We see load in initial domain field, so that can tell us more about the domains. We see so many different things. At the beginning as well, we see auth, which represents authentication, EX, more, and then client. So it looks like here there's something related to authentication, to client authentication, or something like that. So all of this text, all of these strings can tell us more about the malware. Now, when we are using, this is IDA-Pro, a part of IDA-Pro screenshot. IDA-Pro is a tool that's used for code analysis, basically mostly static code analysis, can be used for dynamic analysis as well. And here we can use these strings to pivot into the code and see where they are being used inside the code. So let's say we followed one of the connect to beer strings, and we can see here that here's the connect to beer receive line, and then we see here is sending or is calling to receive line, is calling to get HTTP response code, to send buffer. We can see that he is doing actually some of these activities. We can dive deeper into these activities. We see here, for example, in part of connect to beer, that he's trying to send connect HTTP request starts with connect, and he's trying to connect to the attacker. So that's some information we can use. So that's basically where you try to pivot through your in malware analysis. You try to pivot through suspicious string. You can use a suspicious API, and you can go through to an important API, and you can dive deeper into the malware to understand where this is being used and how it's being used. And even without fully understanding the code, you can still understand what probably this malware is doing, and how the whole flow of the code looks like, so you can understand more about the malware. If you are studying assembly and you want to be a malware analyst, then this string pivot can help you shorten the time you spend analyzing your malware. So you don't analyze 100 functions or 1000 functions. You analyze the important functions and get, as soon as possible, some important information to the incident handlers or to the team you are working with, and answer the most important questions early on. So that's about code analysis. And now we'll talk about something more in depth in that, which is the malware functionalities. So we see different type of malware. They use very similar techniques. There's like templates sometimes are being used over and over again. And seeing these patterns inside a malware can tell you a lot about this malware goal and motivation. And as well, it can help you at some point identify the malicious ones from the clean, legitimate applications. So we'll start with the droppers and downloaders. And these are very, very common, especially in the early stage of an attack. That could be not just an executable, but it could be a malicious document, like the one we saw in the basic static analysis demo. And this document included basically a PowerShell command that downloads from a URL a file into the disk or onto the memory and executes it. So we see this type of downloaders over and over again. We see also programs that actually, or a malware that's actually just a downloader for another malware, an executable.exe file that downloads another malware and install it and then delete itself. And droppers also have something similar, which basically they mostly have their malware either in the resource section, in the resources, or it's somewhere else inside the file. And they use sometimes APIs like find resource, load resource, and size of resource. These Windows commands, help them finding specific resource inside their resources section and able to find their own executable file that's saved inside the resources, drop it on the disk, and then execute it. You can use a tool called Resource Hacker, which is a very known tool to examine the whole resource section and see all the files that's included, all the icons, all the different binary data, all the zip files, all the executable files that are saved in the resources of any executable file. This is how it looks like, the Resource Hacker. And you can see here that this malware is basically called Conflicker. It was a very known malware a long time ago, and it includes here in RC data. The first file, or the first file inside the resources, is basically an MZ file. You see here that this file starts with MZ. It has the text, this program cannot run in DOS mode, and it has the BE after. So it tells you that this file is basically a malware. And you can, or basically an executable file. You can dump this file and start doing the whole malware analysis process on this file directly and see what it's doing. So that's one of the things we see over and over again. It's easy to detect early on in the basic static analysis, even with using Resource Hacker. Also, we see downloaders like the one we saw before in the PowerShell. This one here is in Visual Basic Script, and you see here that he check for PowerShell, and then he execute PowerShell to download a file from this IP. It looks like it is the attacker IP, and he download power.ps1, which basically he executed and includes more commands and includes more about the malware. And this is very similar to the code we saw in the basic static analysis, and here he's using another way to just execute a PowerShell command that downloads a malware. So this is one of the examples. This is another example of some code, basically a PowerShell code that downloads a file from firesys.net, download an executable file, save it in a specific path, and execute it. This code is a PowerShell code. You might not identify it easier now, but when you are more experienced with PowerShell, you will understand this code that's PowerShell, and you will know how it looks like a verb, and then the name of the module, and then continue. So that's for droppers. And now look at keyloggers. And actually, will be the last one because we are really short in time. So with keyloggers, you will see that normally with any keylogger, you will see this keylogger will try to get all the keys that are being pressed, getting the window that is actually these keys are used at. Let's say, is it in Chrome browser? Is it in a chat app? Is it, and also the window title, because sometimes Chrome, it's all the applications are Chrome, all the websites are Chrome browser, but you can see in the window title, when you choose the Gmail tab, you can see that Gmail login in account or something like that is being written in the title. So you will know that these messages are being written inside Google login account page. You will know that this is the username and password is being written here. So keyloggers are mostly using some Windows commands, some APIs that actually gets the keystrokes, which is get key state and get assigned key state. They are getting the window name by using get foreground window, get window text. Some of them are taking screenshots, and screenshots is a type of painting type of commands, something like create compatible DC, create compatible bitmap, which is picture stuff, and bitbuild. So these commands are used to print pictures, copy pictures from a window to or from all the windows to a picture, to a JPG picture or bitmap picture, and it's taking screenshots is commonly used by malware to deal with virtual keyboards. Also, they use get cursor pros or get cursor position command to know where exactly the mouse at, so they can basically paint a complete picture on what exactly the keys the victim has used to write his password. Virtual keyboards are not common as much anymore, but things like KeePass or LastPass or any password vault is more common now. And they also keyloggers, we see now keyloggers are looking at the clipboard data and try to get information from clipboard data. Example of keyloggers, you can see sometimes malware has a code like that. Get key state, get assigned key state, which is determine if the key is up and down for shift, for capital, for or capital or caps lock on, for stuff like that. And then another get key state, and you see that in a loop. So that tells you that probably this malware is basically is a keylogger or has a keylogger functionality up here. See something like this: get foreground window, get window text, allocate, get window text length, and then they get the window text, and then print Windows title, this. So you can see here that in this code that the malware is getting the window name and basically write them somewhere in a string template, which is between brackets, window title, then double dots, then the name of the window. We can clearly see that even if we don't understand any line of the assembly code, we can see just the names of the APIs and the flow of the code that tells us that this part actually get the window title to be saved in the keylogger log file. This is basically some of the keylogger functionality. Also here, this is basically a screenshot of a malware that tries to take a screenshot. We can see that he's using create DC with display. He's using create compatible bitmap, and create compatible DC, create compatible bitmap, and then bitbuild. And from seeing that flow, it can tell us that this is probably an application that takes a screenshot of the device and save that screenshot somewhere. So that is also something common in keyloggers. All of these functionalities can tell us more about the malware functionality, all of this flow of commands. And then you don't need to understand the assembly code for all of that. You just needed to understand the flow of these APIs, the use of the strings in the middle of these APIs, and understand the malware through that. And as well, understand the malware functionalities. How a keylogger would look like, how a dropper would look like, how a downloader would look like, and see that behavior over and over again. And through experience, you will understand malware analysis, and you will have some decent skills to understand the malware, even if you are not skilled in assembly language or the scripting language that's being used. If you want to dive deeper into malware analysis, there is a book called Mastering Malware Analysis. I have authored it 2019 with Alexey Klemenov, and he's also a senior malware researcher in Symantec, or he used to. This is basically, this book, you can say it's like your malware analysis Bible. It has lots of information to get you started in malware analysis, so dive deeper into malware analysis, as well as it covers all the common, not common, and rare cases you might face in real world. In assembly, in Windows malware, in Linux malware, in Mac malware, iOS malware, IoT malware, scripts, interpreted languages from Java, from Python, from Visual Basic 6, from .NET, from different scripting languages, from PowerShell, from Visual Basic Script, JavaScript, and so on. It covers so many different things that can help you deal with an unknown malware if you don't know what to do with it. And if you're starting in malware analysis, this book will tell you lots of things on how to analyze a malware, and it will help you through this process, as well as we have a complete malware incident response training, which covers what we have covered in the previous module, and this module way more in depth. It's basically a complete malware analysis training from A to Z. It's 40 hours, more than 40 hours actually. It's hands-on, step-by-step. Most of it are videos step-by-step. I know that this training has been more presentation, but malware incident response training is mostly hands-on, mostly step-by-step analysis. And not only this, you will get a direct access to me through live Zoom calls, to ask questions, to share your screen, to get me to review your analysis, get my direct feedback, my advice, my insight, all along the way while you are learning malware analysis and incident response. We mainly talk about incident response from the investigation part, where you investigate an attack that's happening on a machine. You can check it out in maltrack.com/join. You will see all the updated information as well. Might be if you look at this training 2 years after, it might not. We might have improved the training and added more and more stuff. So this training is getting updated over the time. Every single time we're adding more and more stuff into that training. So check it out in maltrack.com/join. And that's it for this module. See you in the next module. Bye bye.